So before we start on propagation of uncertainty, just some key terms. So the absolute uncertainty is, let's say we have a reading that looks like this. It's just the actual uncertainty reading. So the uncertainty, we're just going to call that uncertainty. And so when we look at the percentage uncertainty, which is taking the uncertainty and dividing it by the actual value, in this particular case, it's quite large. So it's 50%. So that's the percentage uncertainty. So sometimes we need to use the absolute uncertainty, sometimes we need to use the percentage uncertainty when we're doing uncertainty propagation. So propagation of uncertainty, these are the rules. Addition and subtraction is really easy. We just add the uncertainties. That's absolute uncertainty. And the multiplication and the division is the harder one. So we have to work out the percentage uncertainties first, and then we just add those together. In your final answer, you just have a single sig fig for your uncertainty, and then you need to adjust your final answer so that your final answer doesn't have more precision than your uncertainty. So we'll just go through an example. So this is the raw data that we're going to use. And so we're going to have the mass of the beaker, we're going to find out how much water there was, and basically by minusing one from the other, so that's the plus or minus, and then we'll do a separate calculation where we work out density and we divide it, we do multiplication and division here, so we need to work out the percentage uncertainties. So here we have mass of water, so the first one was plus or minus 0.01. And these are in grams, and so this is just plus or minus, so we add the absolute uncertainties together, and so this is what we have for our final mass, is plus or minus 0.02. Now we take that plus or minus 0.02 here and divide it by the total value to get a percentage uncertainty, because now we're working out the density, so it's mass on volume, and from the data table we had the water here is plus or minus 0.5. So because this is now a division calculation, so this is a times or divide calculation, we're not using absolute uncertainties, we're using percentage uncertainties, so we put the 0.5 divided by 10.2. Okay, sometimes it's easier just to have your uncertainties as a separate column. This one's a fairly simple one, I've just put it within the actual calculation of density. So the actual calculation of density is 0.9833, and we're going to change that based on what the real uncertainty is. So timesing those things out, we get to these numbers here. So we can add the percentage uncertainties here, and we get about a 5.1% is our uncertainty that's carried through because of the two uncertainties that we have divided. And so when you times that out, you are going to get a reading of 0.05 once it's worked out to 1 sig fig. And so this therefore is in the hundredths, and so you need to get rid of these in untruthful precision, and that is your final answer, 0.98 plus or minus 0.05.